All right, another short presentation. We're going to review Chapter 20 in the Electrical Motor Controls textbook. Again, we're going to skip through 20-1, 20-2, and 20-3 relatively quickly. Then when we get to fuel cells, we'll slow up a little bit and talk about, some of our renewable options. And so we're talking about rectifiers. A little review here. When we look at any sort of DC power supply, normally we have a transformer to convert our AC down to a usable voltage, a rectifier to convert it into pulsating DC, a filter to get that DC as close to flat as possible, and then a voltage regulator to get it to whatever set voltages we would like, and then finally a voltage divider to divide it up to power that we can actually use and voltages that we can actually use. Half-wave rectifier converts it to half-wave pulsating DC, like illustrated on the slide, versus a full-wave rectifier, which gives us full-wave pulsating DC, and a bridge rectifier, which also gives us full-wave pulsating DC. Again, hopefully this is a good review. You can use an oscilloscope, probably the best way to see your voltage sources. Then 22 DC power supply filters. There again, the filter, like it shows at the bottom of the illustration there, flattens out the pulsating DC as much as possible, so that we get close to a flat line. There again talks about an L section versus a pi section and the various filtering that can take place there. Again, we're not dealing too much with the regulators, DC power supplies. We're here primarily for the renewable, but again, we're looking at DC power, or the DC power that's available. Here we're showing a voltage regulator. Again, it allows us to set, in this case with a 7.5 volt Zener diode, our expected output will be right around that 7.5 volts. And again, as we load the circuit, it would go down slightly, but that Zener is going to do a pretty good job of holding us at 7.5 volts. Okay, then I said fuel cells. Fuel cells we're going to talk about. A fuel cell, it says, an energy source that transforms chemical energy from fuel into electrical energy. Fuel cells are very efficient, and they usually use a small amount of fuel to get the process started, and then can actually function by themselves, especially when we're talking about hydrogen fuel cells. The fuel cell, kind of shows there's an anode and a cathode, and between the two we can run our power. We have a load. The electrolyte allows for the combination of the hydrogen and the oxygen back into water. Water is usually the only discharge from a fuel cell. The biggest issue with fuel cells is they heat up quite a bit. So it says, positive, negative, how are fuel cells connected to increase current versus voltage. Again, that's series versus parallel again. And then when we talk about photovoltaic cell, is sensitive to light, produces voltage, when it is exposed to light. The symbol is just that of our battery, only with the circle and the arrows pointing in to indicate that it is absorbing the photons of electric light and converting them into power. Photovoltaic cell generates with the PN junction again, just like a diode, and converts that sunlight into electricity. And then just like before, we series them together to increase the voltage. We parallel them together to increase the available current. And it says that on the slide, parallel to increase current output, series to increase voltage output. Probably helps with your fuel cell questions from the previous couple slides. Then the photovoltaic effect, produces free electrons, that then have to travel through conductors, to get into those electron holes. Again, electron flow versus hole flow. when we have a circuit there, we can use a photovoltaic cells as a DC power source, or run them into an inverter and turn them into AC. Again, that's the other part of the class here, is talking about renewable power sources. And troubleshooting DC supplies, again, half wave, full wave, and Zener diode voltage regulators. Again, we were more concerned with the fuel cell portion and the photovoltaic cell portion. So those are the main points here. Again, that about does it for this slide series.